Today we're going to be talking about an optimization problem where we have a box. So an open box is to be made from a 16-inch by 30-inch piece of cardboard by cutting out squares from equal sides from the four corners and bending up the sides. What size should the square be to obtain a box with a maximum volume? So let's write an equation for volume. Volume is length times width times height. So our volume in this case, the height is x, which is this length here, which is what I'm cutting out. The width is 30 minus 2x. I started with 30, but I've cut out x from both sides, so that's 30 minus 2x. And our length is 16 minus 2x. Now our domain restriction is 0 is less than x is less than 8. Because if I cut more than 8 inches from our width, I couldn't cut 9 inches from one side and 9 inches from the other side because I only have 16 inches that I'm able to cut, and I need to cut equal lengths from both sides. Okay, foiling that out. I'm not going to bore you guys with FOIL because that's an Algebra 1 skill. Now we take our derivative of volume. Now set that derivative equal to 0. I'm going to factor out a common factor of 4. And then I'm going to factor that guy even more. Okay, so now set each one of those factors equal to 0. So we get, in this case, 10/3 and 12. But let's look at this. 12 isn't in our domain, so 10/3 is the only one that's in our domain. So now we need to show this using, now we need to prove that this is a maximum or a minimum. So on my little number line chart, I'm going to put 0, I'm going to put 8 because those are my domain restrictions. Luckily you realize 10/3 happens in between. And we're looking at the sign of our derivative. So if I plug in, say, 1 into our derivative, if I plug in 1, I get a negative times a negative, which is a positive. So I'm increasing. And then something between 10/3 and 8. I'm going to plug in 4. Here I get a positive, but here I get a negative, so I'm negative, so I'm decreasing. So I change from my derivative, I apologize, changes from positive to negative. So therefore we have a max at x equals 10/3 because v prime of x changes from positive to negative. Okay, so again, let's make sure that we are giving our dimensions. So what size should the square be? Oh, what size should the square be? So that's all I have to do. I don't have to give dimensions. We just have to give that our square is 10/3, and let's make sure you give me units, inches by 10/3 inches since it is a square.